Hello everyone, my name is Meenakshi. I am from BSc Chemistry Honors second year. Today my topic is acid and base. Explain Arrhenius concept of acid and base. What are the limitation of this concept? Svante Arrhenius, as a part of his theory of ionization, proposed a theory of acid and base according to Arrhenius theory. An acid is a substance that dissociated in aqueous solution to give hydrogen ions. Those HCl, HNO3, H2SO4, CH3COH, and HCN are acid because they liberate H positive ion when dissolved in water. HCl3 are liberate H, H positive ion in the water, dissolve in the water, H positive and Cl negative. A base is a substance that dissociate in aqueous solution to given hydroxyl ions. Those NaOH and KOH, BaOH2 and NH3 are bases because they liberate OH negative ions when dissolved in water. NaOH Na positive plus OH negative. QH in water K positive plus OH negative. Hydronium ions S3O positive. According to Arrhenius, and an acid release as positive ions in aqueous medium. However, it has been found that as positive ion cannot exist independently. In fact, as positive ion is unique among ions. It has no electrons. Its radius is equal to that of nucleus 10 raised to power minus 30 centimeter. The concentration of charge in such a small volume make the attraction between water and H positive ions extremely large. H positive ions accept a pair of electrons from water molecules H bond O bond H to form hydrates, proton or hydronium ions. Dissociation of hydrochloric acid in aqueous solution may be represented as HCl plus H2 react करके H3O positive plus Cl negative. Limitation of Arrhenius theory to explain acid base concepts. Limit scope. Arrhenius concept is limited to aqueous medium only. It fails to explain the behavior of acid and base in non-aqueous solvents like ammonia, sulfur dioxide, alcohol, etc. Proton in aqueous solution. According to Arrhenius concept, acid are those which furnish S ions in water. H positive ions is nothing but a proton which is not capable of independent existence. As already discussed, it may exist a hydronium ions, example as 3O positive. Acid and base without S positive and OH negative ions. There are a number of substances like CO2, SO2, NO2, SO3, etc., which do not contain H positive ions but behave as acids. Similarly, compounds like CaO, MgO, anhydrous, HNO3, NH3, Na2CO3, etc., which do not contain OH negative ions behave as base. Neutralization without H positive and OH negative ions. Neutralization between HCl and NH3 does not involve H positive ions and OH negative ions. Example NH3 plus HCl react to form NH4Cl. CaO plus SO2 react to form CSO3. Explain Bronsted-Lowry concept of acid and base. Z- N. Bronsted and T.M. Lowry independently and simultaneously put forward a more general concept for acid and base. According to the concept, acid is a substance which has a tendency to donate a proton to any substance, and a base is a substance which has a tendency to accept a proton from any other substance. In other words, an acid is a proton donor and base is a proton acceptor. In effect, acid base reaction involves transference of protons. That is why this concept is also called proton transfer theory of acid and base. In accordance with this broader definition, an acid or base may be molecular or ionic. Example: molecular acid HF, HCl, HNO3, H2SO4, CS3COOH, H2S, H3PO4, H2, etc. Ionic acids H3O positive, NH4 positive, HSO4 negative, HSO negative 3, SPO4 2 negative, etc. Molecular bases RNS2, NS3, S2O, R2NH, etc. Ionic bases OH negative, S2 negative, CO3 2 negative, Cl negative, Br negative, NO3 negative, etc. It is important to note that no single substance is an acid or a base. A single substance cannot donate a proton unless and until some other substance which accepts the proton is also present. This proton transfer may or may not involve any medium. Example: the reaction NH3 plus HCl react to form NH4 positive Cl negative. Does not involve any medium. Here HCl has donate a proton to NH3, hence HCl is an acid with respect to NH3, which is a base. Consider some more acid base reaction. NH3 plus NH3 is base plus S2 acid to react to form NH4 negative plus OH negative. CS3COOH plus NH3 react to form CS3COO negative plus NH4 positive. HCl plus S2O react to form S3O positive plus Cl negative. S2SO4 plus S2O to react to form S3O positive HSO4 negative. A careful study of the above equations reveals that water is an acid with respect to NH3, whereas it is a base with respect to HCl or H2SO4. Such substances like H2O, HCO3 negative, HSO4 negative, etc., which can act as acid proton donor as well as basis proton acceptor are called amphoteric and amphiprotic substance. Conjugate acid base pair. When an acid loses a proton, the residual part of it will have a tendency to accept a proton, thus it will behave as a base. Such pairs of substances which differ from one another by a proton are known as conjugate acid base pair. Consider a journal example of an acid Ha acid to react to form H positive proton plus A negative conjugate base. HCl donate a proton to water in the forward reaction. Therefore, HCl is an acid and S2O is a base. In the backward reaction, S3O positive is donate its proton to Cl negative ions. Therefore, S3O positive is an acid and Cl negative is a base. HCl plus S2O to form S3O positive plus Cl negative. It is clear that HCl loses a proton and forms Cl negative, which is a base. HCl and Cl negative ions are called conjugated acid base pair. HCl acid is equal to H positive plus Cl negative Cl negative is conjugated base. Prove that all Bronsted base may not be Arrhenius base. According to Arrhenius base must furnish OH negative ions in aqueous solution. According to Bronsted theory, as a base must accept a proton. Consider for example carbonate ion CO3 to negative. According to Bronsted theory, CO3 2 negative ion is a base as it accepts a proton to form HCO3 negative ions. CO3 2 negative plus H positive react HCO3 negative. According to Arrhenius concept, CO3 2 negative is not a base as it does not furnish OH negative ions in aqueous solution. Hence, all Arrhenius acid are also Bronsted acid, but all Bronsted base are not Arrhenius base. Explain Lux fluid theory of acid and base. This concept was proposed by Lux and later extended by Flood. It visualizes the acid-base reaction in terms of oxide ions is mainly used for molten oxide at high temperature. According to this concept, an acid is a substance which accepts the oxide ion and a base is a substance which donates the oxide ion. Is other words, an acid is an oxide ion acceptor and a base is an oxide which oxide ion donor. For example, in the reaction CaO base plus SiO2 acid to react to form CaSiO3. Calcium oxide is a base and silicon dioxide is an acid. Similar in the reaction PbO plus SO3 react to form PbSO4. PbO is a base while SO3 is an acid. This concept has only limited scope. Give Lewis definition of acid and base given substance examples. According to Lewis, an acid is defined as a molecule, ion, or radical that can accept one or more electron pair. That is, an acid is an electron pair acceptor. In other words, a substance which has vacant orbital of accommo- accommodate one or more pair of electron can act as a Lewis acid. A base is defined as a species that can donate one or more electron pairs. Example, a base is an electron pair donor. Co- Consequently, any substance with unshared pair of electron can behave as a Lewis base. Acid base or neutralization reaction may therefore be termed as donor acceptor reaction or coordinate covalent bond formed reaction as shown below. Acceptor BF3, donor NH3, donor acceptor compound neutralization product S3N to form BF3. Acceptor SNCl3 for donor 2 R2O, donor acceptor compound neutralization product bracket R2O bracket 1 2 SNCl4 as positive donor NH3, donor acceptor compound neutralization product NH4 positive, FeCl3 acceptor, donor is Cl negative, donor acceptor compound neutralization product FeCl4 negative, SO3 acceptor, O2 O2 negative donor, SO4 2 negative donor receptor compound neutralization product. What are different kind of Lewis acid? This can be classified into the following two categories. All the cations are Lewis acid because they have tendency to accept electron pair. Larger cations of alkali and alkaline earth metals behave as relatively weaker Lewis due to their lesser tendency to accept electrons. Smaller cations like S positive, Li positive, B 2 positive, etc., are likely to act as stronger Lewis acid due to their higher tendency to accept electrons and from stronger bonds. Also, higher charged cation have a higher tendency to accept electron relative to the lower charged cation of a given metal. For example, Fe3 positive behave as a stronger Lewis acid as a compound to Fe2 positive. Similarly, SN4 positive is a stronger Lewis acid than SN2 positive. Electron deficient compound in which the central atom can expand its valence shell can behave as Lewis acid BF3, AlCl3, ZaBr3, BeCl2 are electron deficient compound and have tendency to accept electron pair to complete their octet. BF3 plus F negative to form BF4 whole square negative. Compound like SiF4, SnCl4, SbCl3, SbCl5, TbR4, SO3, etc. also represent Lewis acid where central atom can expand in valence shell. What are the different kind of Lewis base? Following two types of compound constitute Lewis base. All the anion can act as Lewis acid because they have a tendency to donate electron pair. For example, oxides O2 negative, hydroxides OH negative, halides X negative, amides NH2 negative, etc. act as Lewis base. The greater the charge density on the anion, the stronger the base. Substance having unshared or a lone pair of electrons act as a Lewis base. For example, water H2, ammonia NH3, ether R2O, ketone R2C, double bond O, etc. act as electron donor and are those Lewis base. What is extended Lewis definition of acid and base? The extended Lewis acid include unsaturated species like CO2 and CS2 where the central atom is bonded to atom of different electronegativity by one or more multiple bonds. Although both the molecules lack accept acceptor character of the central atom because carbon atom cannot extend its octet. Yet these have been indirectly treated as a Lewis acid. This is due to the polarization of the pi electrons. Coulomb approach of a Lewis base toward carbon atom of CO2 or CS2. The polarization leads to a partial positive charge on carbon and a partial negative charge on the more electronegative atom like O. The positively charged carbon then act as an electron acceptor as shown the reaction of CO2 with Lewis base. The extant Lewis base includes substances like carbon monoxide and unsaturated hydrocarbons like alkenes, alkynes, butadienes, benzene, etc. These may be treated as Lewis base because of a lone pair on CO and donating from above mentioned hydrocarbons to form pi complex with metal in low oxidation state. Thank you.